I wanted to go through and just do a review of all the linear equation stuff we've done so far, since we have a test coming up here. So we're going to start with slope. So one of the most important parts of a line, or characteristics of a line, is the slope of the line. So we know slope tells us how steep it is. The way we define slope, though, is slope is equal to the vertical change compared to the horizontal change. A lot of times you'll see this. Right? Vertical change is the change in y. That little triangle means change compared to the change in x. Another way we think of it, you probably all heard this before too. Rise over run. And we have a formula. The way the formula is we go the change in y. You subtract the two y coordinates, y2 minus y1 over x2 minus x1, right? So the y2 minus y1 right there, that's the change in y. And the x2 minus x1 is the change in x. So you'll have to, given a graph, you'll have to be able to find the slope of the line. When you do that, be really careful. Make sure you identify exact points. So sometimes you'll have points that are really close to crossing through, but not exact. So we could use that point, or that point, or that point, or that. There's a point right there. So any of those points are good. And then we're just measuring up and down. Be really careful when deciding if it's positive or negative slope. I would suggest looking at the graph first and deciding is it positive or negative before you do anything else. So if you look at this, the way you tell is this line is going down from left to right. That means it has negative slope. So I would always go from left to right. And when we measure slope, pick 2 points. I'm going to use that one and that one. And I'm going to say it's going down 1, 2, 3, and it's going over 2. Right, so slope is the ratio of the vertical change to the horizontal change. So the slope of that line we would say is vertical change, it went down 2, down 3, excuse me, and horizontal change as it went over 2. So the slope of the line is a negative 3/2. You'll also be asked to find the slope of the line given 2 points. So let's say I have these 2 points right here. I want to find the slope of the line that passes through the point 3, negative 1, and 2, 4. Well, we can use our slope formula for that. So our slope formula is subtract the y's on top, subtract the x's on the bottom. When you go to do this, you can choose the order you go in. So what I mean by that is you can either go 4 minus negative 1, right? I took that y minus that y. But if you do that, the x's have to go in the same order. So it has to go that x minus that x. So that comes out to be, that changes to a plus. 5, 2 minus 3 is negative 1. 5 divided by negative 1 is a negative 5. Now, if you were to switch it around, this is why it doesn't matter what order you go in. If you go negative 1 minus 4 over 3 minus 2, you end up with negative 5 over 3 minus 2 is 1. Hey, you get the same thing. It's still negative 5. So it doesn't matter if you go, which y goes first. Just make sure that if I take that y minus that y, it has to be that x minus that x, or vice versa. Okay, so finding the slope of the line. That's something you'll need to know how to do. Okay, the second thing we're going to talk about is if the equation is in slope-intercept form. We use this slope-intercept form a lot. It's really important. Slope-intercept form means that y equals mx plus b. M is the slope, and b is the y-intercept. So if I want to graph a line and I have it in slope-intercept form, like look at this example up here. I have y equals negative 3x minus 5. That means negative 3, or I'm going to write it as a fraction, negative 3 over 1. That's the slope of the line. Okay, and the minus 5, that is the y-intercept. Okay, so let's start this off. We're going to go down to, start with the y-intercept always. Be really careful. A really common error is I see people put it on the x-axis. It's not there. It's on the y-axis. So just be careful. It's the y-intercept. So go on the y-axis, go down to negative 5. And then be really careful with the slope. If the slope is negative, that means the line has to be going down from left to right. So I can either go down 3 and over 1, or I could go up 3 and left 1. Okay, either one of those are good because the line's going down from left to right. You could even go further, you make as many points as you want. Okay, grab a straight edge, draw the line that passes through that, and we have the graph of the line. So that's one way we graph. If the equation's in y equals mx plus b, or you can put it into y equals mx plus b, then you can graph the equation that way. The other way we graph lines, there's two other ways we did it, is, I'm going to skip past the special cases and we'll talk about that in just a second. But the other two ways we did it is using a table and finding the x and the y intercepts. So let's do this example right here. We want to graph 3x minus y equals 9. So if I'm using a table, make an xy table, I pick the values for x to plug in. So let's just pick something to plug in for x. We could do, for example, 0. And then I plug 0 in for x and find out what happens. So I would go 3 times 0 minus y equals 9. Well, 3 times 0 is 0. That's like a negative 1y, so divide by negative 1. So y is equal to negative 9. Okay, let's pick another number. We could do, for example, 2. So if I go 3 times 2, so let's put 2 in for x. 3 times 2 is 6, minus y equals 9. So let's minus the 6 over. Minus y equals 3. Again, that's like a negative 1y. Divide by negative 1. So y is equal to a negative 3. Let's pick one more number. Let's just do 3. So I plug 3 in for y right there. 3 times 3 is 9. Okay, so minus the 9 over. So negative y equals 0. It's like a negative 1. So I get 0 right there. So all you're doing is you're picking values for x, and you get to choose the values for x. That's up to you. You plug them in and find out what the y values are. Okay, let's take those 3 points and put them on our graph. So we got a point at 0, negative 9. I think that goes down to 8. So that might just be, let's count one more. 1, 2, 3, 4, 5, 6, 7, 8. 9 would be down one more down there. 2, negative 3. 3, 0. Okay, and then all we're going to do is grab a straight edge, connect those points, and we have the equation of the line. Okay. So that is using a table. The second way we did it, let's come down here, is by using x and y intercepts. So I'm going to take that same equation. Let me just slide it down a little bit here so we can still see it. I'm going to take that same equation and find the x and y intercepts. So here's how we did it. To find the x intercepts, you plug 0 for y, and you find x. To find the y-intercept, you plug 0 for x and find y. So let's do both of those. So it's going to look like this. I start out, I'm going to plug 0 for y first. So it looks like this. My point's going to be the y coordinate has to be 0. This is just like a table like I did up above. In this case, though, I'm putting 0 in for y right there. So I get 3x minus 0 equals 9. Well, the minus 0 just goes away. So I end up with 3x equals 9. So find out what x is. So if I divide by 3, 9 divided by 3 is 3. Okay, there is my x-intercept. Right, so I come onto my graph. I'm going to pretend like I hadn't already graphed this. Just take that off for a second, maybe, if I can here. So let's pretend like we hadn't already graphed this. I'd come over here and say, okay, my x-intercept is at 3, 0. So that point's right there. Okay, now if I want to find the y-intercept, we plug 0 in for x. So this time, I plug 0 in for x, and I find the y. Well, if I plug 0 in for x, now the 0 is going right here. So I get 3 times 0 is 0, minus y equals 9. Well, the 0 just goes away. That's like negative 1, so divide by negative 1. So I get negative 9 for y. So that's my y-intercept. So again, that falls a little bit off my graph. That'd be somewhere down in there. Grab my straight edge, right? We get the exact same line as we got by graphing a table. So that's using the x and the y-intercepts. And I'll ask you to do that on the test. I'll ask you to find the x-intercept. I'll ask you to find the y-intercept. Okay, the last way is the way we just talked about. I'm going to erase this up here so we can fit all this in. The last way we can graph is slope-intercept form. But I wanted to show you this example. So if you look at this one, this time the equation, right, that equation is not in the y equals mx plus b. So it's not in the right form. So we have to put it in that form if we're going to use that method. So you always start by subtracting the x term. So I'm going to minus the 3x over to that side. So I have negative y equals, instead of being 9 minus 3x, I'm going to flip them around. Make sure the minus stays with the 3x, and the 9's a positive, so it's plus 9. Negative y is like a negative 1, so divide by negative 1 all the way through. So I end up getting y is equal to a negative 3 divided by a negative 1 is 3, and 9 divided by a negative 1 is a negative 9. So there's my slope-intercept form. So 3 is my slope, right, that's m, and negative 9 is my y-intercept. So now I come over to my graph. I'm going to start, again, I know this is a little bit off our graph here, but I'm going to start at negative 9. That's my y-intercept, and then I'm doing a slope of 3, which is really 3 over 1. So from there, I'm going to go up 3, 1, 2, 3 over 1, up 3 over 1. And we can do that as many times as you want. But again, that's going to give us the exact same line as we already had. So there's 3 different ways to graph, and I'm going to ask you to know each of those. So I want you to graph the table. I want you to find the x and y intercepts and be able to graph it. And I want you to be able to put it in slope-intercept form and be able to graph it. Okay, really the last thing we did was to find the equation of the line. So when you're asked to find the equation of the line, you have 2 options. One is you can use the y equals mx plus b. This is the easiest form, and to use it, I have to know the slope, but I also have to know the y-intercept. Whoops, sorry. I have to know the y-intercept. The other option is this called point-slope formula over here. To use this equation, you still have to know the slope. But you also have to know, but you can use any point on the line. So x1, y1, supposed to be an x there, sorry. x1, y1 is any point on the line. So if you're given the y-intercept, this is the easiest formula to use right here. But if you don't have the y-intercept, if you just have a point, then you've got to use this formula over here. So that's part of the process. You know, the first step is deciding which formula to use. Okay, so let's do this first example. It says find the equation of the line that passes through the point, that has a slope of 3/5 and passes through the point 0, negative 5. Okay, so decide on the right formula. I would rather use this one up here, the y equals mx plus b, but I have to know the y-intercept. So the question is this the y-intercept? So think about where 0, negative 5 is. 0, negative 5 is right there. It is on the y-axis. So negative 5 is the y-intercept, or it's b. And 3/5 is m. All I have to do is plug those 2 things in my formula then. So the equation of my line is y equals the slope, 3/5, and the y-intercept's a minus 5. So it's really, really simple to use that formula, but you have to know the y-intercept. Hey, by the way, if you use the point slope, this one up here on that problem, you get the same answer. It just requires a little more work. Okay, so let's do this next example. So this one says, find the equation of the line that passes through the point 2, 4, and 4, negative 3. Okay, so first thing is you have to know the slope on either of those formulas. If you don't know the slope, then you need to find the slope. And we know how to do that. We just did that. We go m equals, I subtract the y. So I'm going to go 4 minus negative 3. Make sure I go in the same order. I have to go 2 minus 4 on the bottom. So that comes out to be, that changes to a plus, is 7. 2 minus 4 is a negative 2. A positive and a negative make a negative. So my slope comes out to be a negative 7/2. Okay, now the next thing is which formula to use. Well, this is not the y-intercept. 2, 4 is not on the y-axis. This would have to be 0, which it's not. And 4, negative 3 is not on the y-axis, so that would have to be 0, which it's not. So we can't use slope-intercept. So instead I'm going to use the point slope, this formula. Okay, so I got the slope already. It's right there. There's m. And then I have to use a point. You choose which point to use. It doesn't matter. I'm going to use this first one. I'm going to call this one x1, Sorry, my board's not wanting to write there, but that one's x1, that one's y1. Okay, you've now plugged the numbers in the formula. So I go y minus my y coordinate, that's 4 right there, equals m, my slope, negative 7/2 times x minus my x coordinate, which is 2. Okay, that's the equation of the line. Now I just have to put it in the right form. So I'm going to times through by the negative 7/2. So I get y minus 4 equals negative 7/2 x plus, when I go 7/2 times 2, 2 over 1, the 2's just cancel out. So plus 7. I'm going to add the 4 over. So the equation of my line is y equals negative 7/2 x plus 11. So that is the equation of the line we're looking for. The last examples, we're still finding the equation of the line, but it's with parallel and perpendicular. So parallel lines, remember, have the same slope. Perpendicular lines, they're lines that cross at 90-degree angles, but their slopes are opposite reciprocals. So what do I mean by that? Let's say I have the slope of one line and I know it's this. The slope of that line is 2/3. Well, that means the slope of the line parallel to it would also be 2/3. But the slope of the line perpendicular to it is the opposite reciprocal. So if it's a positive 2/3, I have to make it a negative, and reciprocal means I'm going to flip it over. So it'd be a negative 3/2. So we can use that information to do problems like this. This says, find the equation of the line parallel to y equals negative 1/2 x minus 4, and that passes through the point 2,5. So first of all, I have a point. That's not the y-intercept, by the way, so I know I'm using this formula. So I have a point, it's 2,5. That's my x1, that's my y1. And then if it's parallel, it has to have the same slope as this line. Well, the slope of this line is a negative 1/2. So the slope of the line I'm looking for also has to be a negative 1/2. So there's my point, there's my slope. Plug in your information. Y minus my y coordinate, which is 5, equals the slope times x minus my x coordinate. Okay, that's my equation. I'm just going to put it in the right form. So times through there. So I have y minus 5 equals negative 1/2 x plus 1. Right, negative 1/2 times a negative 2 comes out to be a positive 1. Add the 5 over. So the equation comes out to be y equals negative 1/2 x plus 6. So if you know the line is parallel or perpendicular to it, you can figure out the slope. If I were to change this problem, let's change it for a second. Let's say instead of saying parallel, it said perpendicular. Okay, if it does say perpendicular, what we're going to do, instead of being a negative 1/2, I have to do the opposite reciprocal. So my slope would be, if it's negative, I have to change it to a positive. And if it's 1 over 2, I have to flip it over and make it 2 over 1, which really means it's 2. So being perpendicular, I know that one's a negative 1/2. My line has to have a slope of 2. And then I'm still going to use that same point. So use the equation of your line. Y minus 5 equals m times x minus 2. Okay, that's my equation. Let's just put it in the right form. So y minus 5 equals 2x minus 4. Add the 5 over. So y is equal to 2x plus 1. There's the equation of my line. That's it on the review. So if you're thinking of all the things you have to do, make sure you know how to find slope. Oh, hey, I'm sorry. There's one thing I forgot about. I told you we're going to come back to it. I never did. Sorry. One last thing. Let's look at these special cases. When you have lines that are either vertical or horizontal, the equations look a little bit different. So if you look at this one, the y equals 4, you could think of it this way. It's like saying y equals 0x plus 4. Right? So 4 is the y-intercept, and it has a slope of 0. So we're going to come up here, come up to 4 is the y-intercept, and it has a slope of 0. That means it goes up 0 and over as many as you want. So you could go up 0 over 1, or up 0 over 4, or up 0 and left 3. It doesn't matter, but the slope has to be 0. So really important, write this down. If you have y equals a number, that means it's a horizontal line, and it has a slope of 0. Okay, if you look at x equals -2, that one's a little bit tricky, but just think about it for a second. That means it crosses the x-axis at -2. So go on the x-axis at -2, and it's just a vertical line. The x-coordinate always has to be -2 no matter where you go. So it's always -2. So x equals -2 is a vertical line, or x equals any number is a vertical line. And what we say about the slope, we talked about this when we talked about slope, but it has been a long time, right? If I go up 3 and over 0, right, the slope is 3 over 0. Well, you cannot divide by 0. What that means is the slope is undefined. So what I want you to know, okay, the two things is, how do you graph it? Well, if it's y equals a number, go up to the y-intercept, put a point, and it's a horizontal line. If it's x equals a number, go to that x-intercept, put a point, and it's a vertical line. And then I want you to know the slope. For a horizontal line, for y equals, a slope is 0. For a vertical line, it's an undefined slope. Okay, so make sure you practice those and know those. Okay, so be able to find the equation of the line using a slope-intercept, point, slope, know how to find slope of a line, know how to graph lines using a table, using x and y intercepts, and putting it in slope-intercept form, and then know these special cases. And that should cover everything that's on the test. Thanks, guys.